Alright, so today we will be doing a quick review on some ideas that you will need to understand for Physics 11. So quickly we'll do a review of scientific notation as well as sig figs. So scientific notation, as a lot of you will know, is defined by the general equation of m times 10 to the n, where m is greater than or equal to 1, but less than 10, and where n is an integer. So this should be a pretty simple review for a lot of you guys. For example, let's say 3 times 10 to the 6. That number will equal to 3 million. Let's do another quick example. 2 times 10 to the negative 3 will equal to 0.002. So the main use of scientific notation is just to compare very large numbers as well as very small numbers. Operations with scientific notation, we can do a quick review of that as well. Let's do an example problem. Let's say 8 times 10 to the 6 divided by 2 times 10 to the 3, and as well as b, let's say 3 times 10 to the 4 multiplied by 2 times 10 to the 5. So if you want, you can pause the video here, just do a quick, write down the answer to that problem, and then you can resume. Alright, so for the first one, what you want to do is you look at the m on both numbers. So the m is 8 as well as 2. You divide those two first and you get 4. And then you look at the 10 to the 6 as well as the 10 to the 3. So since you're dividing the exponents, you know that it'll be essentially 4 times 10 to the power of 6 minus 3, which will equal to 4 times 10 to the 3. And let's look at the second question. So let's look at the m. You have 3 and also 2. You're multiplying those two together, so you'll get a 6. And since you are multiplying the exponents, you will essentially be adding the 4 and the 5, so that would be 10 to the power of 4 plus 5, which is equal to 6 times 10 to the 9. All right, that should be pretty simple. So now we'll be moving on to sig figs. So sig figs are defined as the valid digits that are used in measurements and calculations. So this is very important for Physics 11. There are instances where answers must be simplified down to their sig figs, and also instances where you can't accept some because there are uncertainties in the answers. So to determine the number of sig figs in any given number, you have to remember these 4 important steps. Four important steps. So the first one is all non-zero digits are always significant. I'll just write sig for short. So non-zero digits are always significant. So any number like 1, 2, 3, all those numbers, they're all significant. Now number 2, all final zeros all final zeros after the decimal are significant. Number 3, zeros between two other significant digits, just call them sig digs. Zeros between two other significant digits are also significant. So let's say you have a number like 309. There's a 0 between the 3 and the 9, which will make it significant. So with a number like that, there'll be 3 significant digits. And finally, the last thing you have to remember is that zeros to the right of a whole number are considered to be ambiguous. So essentially what this means is that they're going to be uncertain, so you can't count them as a significant figure. So let's say the number 2039, for example. 2039, well, let's look at the rule. Non-zero digits are always significant. So we have a 2, we have a 3, we have a 9. All final zeros after the decimal are significant. Well, there's no decimals in here, so we don't have to worry about that. Zeros between two other significant digits are significant. So let's look at the 0. It's between a 2 and a 3, making it significant. So in total, for 2039, there will be 4 sig figs. However, if we have something like 2,390, if we look at the rule, zeros to the right of a whole number are ambiguous. You can see that 0 is by itself here on the right. It is not surrounded by 2 other sig figs, making it ambiguous. So for 2,390, there'd be only 3 sig figs. And let's just do some quick practice. A few questions. You can pause the video, do the questions, and then resume once you have all the answers. So for these, just write out how many significant figures are in each number. All right, so for question A, the number 2084, using the rules that you saw above, you'll know that there are 4 sig figs. B, that'll be 3. C, that'll be 1. D, that'll be 3. E, that'll be 3. And F, that'll also be 3. All right, moving on to operations using sig figs. So when you are adding and subtracting sig figs, you have to round the answer to the number with the least precise decimal. So let's say you have a equation like 24.7314 plus 3.69 is equal to, if you put this into your calculator, you will get 28.4214. However, because you're dealing with sig figs, you're going to have to round that. So like I said before, when you're adding and subtracting sig figs, you have to round the answer to the least precise decimal, which in this case is the 3.69. There are only 2 decimal places compared to the 4 that's in the other number. So what you want to do is you want to round this answer to 2 decimal places. So you get 28.42. Now you have to remember that when you're adding and subtracting, you're not rounding to the number with the least amount of sig figs. You're rounding it to the number with the least amount of decimal places. When you're multiplying and dividing sig figs, however, it's slightly more simple because, let's say you have a number 23.5 times 4.9. When you put that into your calculator, you will get a number of 115.15. Rounding to the sig figs, it's going to be slightly different from adding and subtracting, where instead of rounding to the least precise number, or sorry, the number with the smallest amount of decimal places, you just round to the number with the least amount of sig figs. So in this case, it is 2. So you have to round this number to 2 sig figs, which will make it 120. Or you could also write it in scientific notation, which would just be 1.2 times 10 to the 2. So yeah, there's slight differences with addition and subtracting that you have to keep in mind. And yeah, that is the lesson done. Thank you for watching. And good luck in Physics 11.